All right, now suppose we want to compute the point of intersection on a circle, but we're given the angle and the radius of the circle. How do we do that? Well, let's take this one for instance. We're saying that the radius is 12 and that the angle is minus 15 degrees. Well, we know that from 0 down to minus 90 would keep you in this quadrant here. So we have actually a fairly shallow angle in this general area right here, and we're trying to compute this point. We've given the formula before that the x and y coordinates of the point of intersection on the circle are always given by r cosine of theta and r sine of theta. And in this case, the plus or minusness, that sign of the cosine and the sine functions, are actually going to be quite helpful to us because they will produce the sines of x and y quite nicely. All right, so we know that our angle is down in here 15 degrees and rotated downward from the axis. So x is equal to the radius 12 times the sine of minus 15 degrees, and y is the radius, that's 12, cosine of minus 15 degrees. And now we can get both of these pretty quickly on our calculator. Probably a good idea to check when you get started, are you in degree mode? We are. And now we want 12 times the sine of minus 15. That gives me minus 3.1058. And the y-coordinate is 12 times, I wrote these backwards. The y-coordinate is 12 times the sine of minus 15 degrees, and the x-coordinate is 12 times the cosine of minus 15 degrees. And that's about 11.5911. Now the cosine product is coming out to be positive, and the product with the sine is coming out to be negative. Does that make sense? Well, sure enough, if we're down here in this fourth quadrant, then it certainly is the case that the y-coordinate is negative, whereas the x-coordinate is positive. So the trig function sine and cosine will keep track of the plus and minus for us in this kind of work.